All right, let's jump right in. Today we're going to pull back the curtain on a secret mathematical language that describes how literally everything around us changes. It's called the derivative, and I promise you, it's way more exciting than it sounded back in high school. Okay, so let's start with a little riddle to get our brains warmed up. What could possibly connect the speed of a car on the highway and a company's profit margin? I mean, they seem like they're from completely different universes, right?
Well, the answer is actually pretty simple, but it's a huge idea. They are both constantly changing. A car's speed isn't just one number, and a company's profit isn't either. They go up, they go down. And this idea of change is exactly what we're going to dig into.
So how do you even get a handle on something that's always in motion? How can we measure the speed of a car at one precise instant, or pinpoint the exact moment a company's profits start to take a nosedive? This is where math gives us an unbelievably powerful tool.
And that tool is the derivative. Now, forget all the complex formulas for just a second, and think of it like this. It's basically a mathematical magnifying glass. It lets us zoom in on any single moment in time and see exactly how fast something is changing, right at that specific point.
Now, to really get this, we're going to use a simple analogy. I want you to just imagine that any function we're looking at, whether it's tracking profit or position, is a landscape. A bunch of hills and valleys that you can actually walk along.
And this right here just nails it. The derivative isn't some abstract, floaty number. It's the steepness, the slope, of the path at the very spot where you are standing. Are you huffing and puffing up a steep hill? Are you cruising down a gentle slope? Or are you standing on perfectly flat ground? The derivative is what tells you.
So let's break this down. If the derivative is a positive number, it means you're going uphill. The function is increasing. If it's negative, you're headed downhill. The function is decreasing. And what if the derivative is exactly 0? That's the interesting part. That means you're standing perfectly flat either at the very top of a peak or the very bottom of a valley.
And this 0 point is absolutely crucial. It's the tipping point, right? It's where the change stops and it's about to reverse direction. This is how we find the maximum height of a baseball thrown in the air, or, like we're about to see, the maximum profit for a company. So the big question is, how do we find it?
Let's do a quick practice run with a pure math example just to see how the mechanics work. So we've got this function here. It describes a curve, a parabola. Our mission, should we choose to accept it, is to find the very bottom of that curve's valley.
So how do we find that tipping point? Well, it's a simple step-by-step process. First, you find the derivative of the function. For this one, it's 6x minus 12. Think of this as your new slope finder formula. Next, we ask the most important question. Where is the slope 0? So we take our slope finder, set it equal to 0, and just solve for x.
And the answer is 2. Boom! At the exact point where x equals 2, the slope of our curve is perfectly flat. We found it. We found the bottom of the valley, our tipping point.
Okay, so that's the math. But who cares, right? How does this actually help us in the real world? Well, let's take this exact same tool and use it to make as much money as possible.
All right, here's a classic business problem. A company's profit, which they call V, depends on how many things they produce, which is X. They have a function that models this relationship. Now, the million-dollar question for pretty much any business is, how many units should we make to get the absolute tippy-top maximum profit?
And here is the beautiful part. We don't need to learn any new math at all. We're still just looking for the top of the hill, the peak of the profit curve. The method is exactly the same one we just used.
So we find the derivative of that profit function, which is v prime of x equals negative 2x plus 20, and you guessed it, we set it to 0. This is going to tell us the exact number of products to make to hit that absolute peak profit.
When you solve for x, you get 10. That's it. That's the magic number. And this isn't just a good guess, it's a mathematical certainty. If this company produces exactly 10 units, they will maximize their profit. If they make 9, or if they make 11, they will literally make less money.
We found the peak of the profit hill. Just like that, the derivative has shown us the way to maximize returns. See, this is so much more than just numbers. It's a seriously powerful tool for making smart, real-world decisions.
Okay, so you've seen the theory and you've seen it in action. Now the absolute best way to make this stuff stick is to try it yourself. Let's put this new superpower to the test with a couple of quick exercises.
Here are a couple for you to try out. The first one asks for an extreme value. That's just a fancy math term for a peak or a valley. The second one is all about minimizing costs, which is just finding the bottom of the cost valley. Remember, the game plan is the same for both. Find the derivative, set it to 0, and solve.
So we've seen how the derivative helps us understand change, to find the top of a hill or the bottom of a valley. But now you have this tool. You can apply it to anything that changes: the spread of a disease, the path of a rocket, the ups and downs of the stock market. The derivative is more than just a math concept. It's a whole new way of seeing the world. So what will you see differently now?